Here is a problem where we have been asked to find the enantiomer of this particular compound from the following options. Here is the Newman projection formula, whereas here we have the perspective formula. So how do we go about this problem? The first thing that you would do is you would determine the number of chiral centers in this molecule. This carbon wouldn't be a chiral center because it's attached to two hydrogens. Similarly, this carbon is also attached to two hydrogens and therefore cannot be qualified to be a chiral center. And again, we already know this is a carbon that's facing towards you, and this is the carbon that is attached to the carbon in the front and it's pointing away from you. And the carbon that is pointing away from you also has two hydrogens and therefore it doesn't qualify to be a chiral center. So the only atom which is a chiral center here is the carbon atom that's facing in front of you. Okay, now that we have determined the number of chiral centers in this molecule, we just need to identify the configuration for this compound. Now, if you look into this carbon right here, it is facing towards you, whereas this carbon is facing away from you. Or in other words, this carbon is connected to the ethyl group because you have a carbon that is attached to two hydrogens and a methyl group. So it is connected to an ethyl group that's away from you. Okay, now we can easily determine the configuration of it if we can assign the priorities of the different groups. Now let's assign the priorities. We have an OH group, we have a CH2Br, we have an ethyl group, and we also have an CH2OH group. Now, which one is going to have higher priority? Obviously, the OH is going to have higher priority because the oxygen is going to have a higher atomic number and therefore it's going to have higher priority. And then between CH2 and between the three other groups, there is a tie, right, on the first atom. So you look into the other atoms that it's connected to. On here, we have bromine, we have carbon, and we have oxygen. So between all of these three different atoms, we already know that the bromine is the one that's going to have higher priority, and that has to be assigned 2. And then the oxygen is going to be, the one that's connected to oxygen is going to be assigned 3, and this is going to be 4. Now that we have assigned the priority, let's see which direction is it going to go on to. So this is 1, and this is 2, and this is 3. Now it's actually going in the clockwise direction with your lowest priority group, which is the ethyl group here in this case, is pointing away from us, and therefore the configuration for this compound is R. Now when you look into the options that are given here, all of these are in perspective formula. At this point, you can keep them as it is and find the RNS configuration, or you can change that into Newman projection formula and then find the RNS configuration. But if you are converting this into Newman projection formula, then you have to look at it at a certain angle. So your perspective formula is going to look more like the Newman projection formula. So here is your inverted Y and here is your upright Y. Okay. And by drawing the Newman projection formula, you're going to find out the configuration where you're going to see whether any one of these carbons is going to have S configuration, which would be the enantiomer of this compound. To begin with, we have an inverted Y. So we're going to draw the Newman projection formula with our OH on the top and the CH2OH going towards your left and CH2Br going towards our right. And I'm going to represent the other carbon as a circle. Okay, now I have an upright Y. Okay, where my hydrogen is pointing down and the other hydrogen is pointing towards my right, and the methyl group is on the left. Okay, now again, we needed to identify the configuration for this compound using exactly the same method. So this is our chiral center, and the bond right here is going away from us, and this group right here is nothing but our CH2CH3 group. Leaving that, we have 1, 2, 3, 4 bonds, and let's assign the priorities. So this will be 1, this would still be 2, this would be 3, and it is again going in the clockwise direction, and therefore this compound is also having the R configuration. Let's do exactly the same thing and find the configuration for the rest of the compounds. For B, the chiral center is right here. Okay, so I'm actually going to look in this angle. Okay, so when I look into that angle, this is an inverted Y. Okay, and this is an upright Y. Right? So let's draw the Newman projection formula for this molecule. So that's an inverted Y where I have OH on the top, CH2Br going right, and CH2OH going towards my left. And this carbon should be represented as a circle. Okay, and I have an hydrogen that's coming towards my left, towards my right, another one coming towards my right, and I have a CH3 that's going down. So this is going down, this is going towards my right, and this is going towards my left. Okay. Now again, here again, you can see that the CH2CH3 group is actually away from us. And if we assign the priority, so this is 1, this is 2, this is 3, and it's going in the clockwise direction, and therefore this compound is also R. Okay, so the configuration of this chiral center is also R. Compound C, let's draw the Newman projection formula. Again, here is our chiral center. This is an inverted Y shape, and this is also an inverted Y shape, and you can see both the structures are, both the groups are eclipsing each other. Okay, so we'll begin with the first carbon. This is our first carbon, and we have CH2 pointing up, and you have OH towards your right, and CH2Br towards your left, and this carbon needs to be represented as a circle. Okay, again, remember this bond is going up, right? CH3, and then you have one hydrogen that's coming towards your right and the other hydrogen going towards your left. So this is the Newman projection formula, and again we can see that this ethyl group is pointing away from us, and we needed to just find the configuration for that by assigning the priorities. So this would be number 1, this is number 2, this is number 3, and this is again going in the clockwise direction. Therefore, it should be R. Finally, let's go on to D. Here is our chiral center. This is an inverted Y, and this is also an inverted Y. This is also another eclipse conformation. Okay, let's draw the Newman projection formula facing with our eyes facing the chiral center. So this is our chiral center, and we have OH that's going up, and we have CH2OH that's towards our right, and CH2Br towards our left. We have the carbon that's facing at the back, and which has to be represented as a circle. Okay, and this is an eclipsed structure because of the two inverted Y's. So CH3 is at the top. So now let's look into the configuration for this. Here again, the CH2CH3 group is pointing away from us, right? And this is going to be carbon number 1, or this is going to be our group number 1 with respect to priority. This is 2, and this is 3. Now you can see that it is going in the anti-clockwise direction, and therefore this is going to be S. So to answer this question, the right answer for this question is this is the only compound which has a switched configuration, and therefore this should be the enantiomer of the compound that is given here.